Sealed interfaces are a powerful feature in Kotlin that allow you to define restricted type hierarchies. They provide a way to create type-safe contracts where all possible implementations are known at compile time. This makes your code more predictable and safer to work with. Sealed interfaces were introduced in Kotlin version 1.5. They allow you to define restricted type hierarchies using interfaces instead of classes. The key characteristic is that all implementations must be known at compile time, meaning you cannot add new implementations outside of the module where the sealed interface is defined. This restriction enables the compiler to perform exhaustive checks in when expressions, ensuring you handle all possible cases. The syntax for defining a sealed interface is straightforward. You use the sealed keyword followed by the interface keyword and the interface name. In this example, we have a result sealed interface. 3 implementations are defined. Success is a data class that holds a string representing successful data. Error is a data class containing an error message, and loading is an object representing the loading state. Each implementation explicitly declares that it implements the result interface using the colon syntax. Sealed interfaces have important differences compared to sealed classes. The most significant advantage is that a single class can implement multiple sealed interfaces, whereas sealed classes only allow single inheritance. This makes sealed interfaces more flexible for complex type hierarchies. You can also combine sealed interfaces with other regular interfaces, giving you greater design flexibility when modeling your domain. Here's a practical example of multiple interface implementation. We define 2 sealed interfaces, payment method and refundable. The credit card data class implements both interfaces, indicating it's both a payment method and can be refunded. The cash data class only implements payment method, showing that cash payments cannot be refunded. This demonstrates how sealed interfaces provide more flexibility than sealed classes, allowing you to compose behaviors from multiple type hierarchies. One of the biggest advantages of sealed interfaces is exhaustive when expressions. In this handle function, we pattern match on the result type. We have 3 branches, one for success, one for error, and one for loading. Notice there's no else clause needed. The compiler knows all possible implementations of the result sealed interface, so it can verify that all cases are handled. If you add a new implementation later, the compiler will flag any when expressions that don't handle it, preventing runtime errors. Sealed interfaces are perfect for several common scenarios. They're ideal for modeling API responses with success and error states, making network code more type-safe. They work great for UI states, representing loading, content display, and error conditions. Form validation results can be elegantly modeled using sealed interfaces to represent valid, invalid, or pending states. And navigation, events and applications benefit from the exhaustive checking, ensuring all navigation paths are properly handled. Let's recap the key benefits of sealed interfaces. They provide type-safe hierarchies with compile-time guarantees, catching errors before your code runs. They're more flexible than sealed classes for complex designs that require multiple inheritance. Exhaustive when expressions eliminate entire categories of runtime errors by forcing you to handle all cases. And they provide clear contract definitions for API boundaries, making your code's intent explicit and easier to understand. Sealed interfaces are a powerful tool for writing safer, more maintainable Kotlin code.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.